Let's do a couple of videos on no calculator projectiles, doing projectile motion problems essentially in our head. So let's start with a couple of things about triangles. To two significant figures, write the length of the hypotenuse of each right triangle shown. These are 45, 45, 90 right triangles, and hopefully you learned in your math class that if you have a length of 1 for a 45, 45, 90 right triangle on the legs, then that means you've got root 2 as the hypotenuse, which is 1.414 or so. Well, if root 2 is about 1.4, then when we have for this triangle 10, 10, this one's going to be 14. And this one is going to be 28. And this one will be what? 1.4 times 40, 56. A 45, 45, 90 right triangle is basically a 5, 5, 7 triangle with edge lengths having a proportion of 5 to 5 to 7 for the hypotenuse. If we use 5, 5, 7, it's only a 1% difference from what it really, really is. So that's a really handy thing to keep in mind. Anytime you've got a 45, 45, 90 right triangle, the edge lengths have the ratio 5, 5, 7. Now, it's also important to memorize, I think, that the significance of a 37, 53, 90 right triangle, and this isn't exact, is that that's a 3, 4, 5 right triangle. So if you see a problem that has an angle of about 37 or an angle of about 53 for a right triangle, that's going to tell you that you have a 3, 4, 5 right triangle. So let's try a couple of problems so that we can see how this works. We're going to solve each of these problems without a calculator. You can see what we're doing here. We're launching something. It's got an initial x velocity. It's got an initial y velocity. And using what we know about the ratio 5, 5, 7, if the hypotenuse is 7, well, that means there's a factor of 6 in there. So 5 times 6, that initial x velocity is 30 meters per second, and that initial y velocity is 30 meters per second. We did that in our head, which means the time to the top, we're assuming everything's on Earth, unless we're told otherwise, and we know that the velocity in the vertical direction changes by 10 meters per second every second. So very quickly we can say it's going to take 3 seconds to get to the top. If I skip down, it's going to be in the air for 6 seconds. We're assuming it's going to land at the same elevation that it was launched from. So what's the maximum height? How did we do this when we were doing one-dimensional kinematics problems in our head? We took the initial velocity in the y direction plus the final velocity in the y direction, cut in half, and then we multiplied by the time. Well, the initial y velocity is 30. At the top, the y velocity is 0, so the average is 15. Let me write that over here. I'm not going to do this for every problem, but I will do it for this one. In going to the top, Vy average is 15 meters per second. For each of 3 seconds, maximum height, 45 meters. What about the range? The range is, as we know, the maximum horizontal displacement, which means over here, right where I'm pointing, 30 meters to the right every second. For each of 6 seconds, boom, 180 meters that way. Maximum height is obviously it's up there like that. That's how you do these in your head. Let's try a couple more here. How about this one? Oh, 53 degrees. Okay, so this is a 3, 4, 5 right triangle. So this is the 5, and this would be the 3 leg, and this would be the 4 leg. And so let's see, if 5 is to 50, as 3 would be to 30, and that must mean that the initial upward velocity turns out to be 40 meters per second. All right, time to the top, 4 seconds. It's going to take 4 seconds to get to the top. The maximum height, What's the average as it goes to the top? The average will be 20 because it stops at the top. So the average is 20, and it does that for 4 seconds. I think it's going to go 80 meters high, roughly. The total time in the air, again, we're going to assume it's going to land at the same elevation that it was launched from, so same amount of time to come down as go up. And the range is going to be 30 meters to the right every second, multiplied by the entire time it's in the air. I think that's going to be 240 meters. Let's do one more in this video. All right, this time we're just given, 30 meters per second is that component. We're not given the initial velocity. We could find that by using the Pythagorean theorem, but I think let's see if we can answer these questions without that. Time to the top. Who's with me? 3 seconds. Maximum height. At the top, it'll have a vertical speed of 0. So the average vertically will be 15 times 3 seconds. 45 meters high is about how high this thing's going to go before it starts coming down. It's going to be in the air for 6 seconds because we're assuming it's going to land at the same elevation it was launched from. And the range will be 80 meters to the right every second for each of 6 seconds, 480 meters. Don't even look at me and say that's not cool. That is cool.